Hey 7th grade, sorry to cut you off so abruptly after video 1. Here we're going to start video 2 with looking at AND scenarios. And just like in video 1, I want to make a connection back to lesson 3.8. So here's a visual for that if you're following along with those notes. Intersection is where we learned that if you have a set A and a set B, the intersection or the AND outcomes are going to be the outcomes that they both have in common. Okay, so if it's in set A but not set B, it would not be considered in an AND scenario. It could for an OR, like we saw in video 1, but not an AND. Okay, so I actually went ahead and I gave 3 visuals here so we can compare our 3 scenarios that we either have looked at or we're about to look at. The first 2 we have already looked at. For the ORs in video 1, we looked at mutually exclusive versus overlapping. So the first one here I actually have is the overlapping. If you have an OR scenario, you're going to add all outcomes of event A and event B, but subtract your overlap. If they're mutually exclusive, there is no overlap, so you're just going to add all the outcomes of A and all the outcomes of B. For AND, we are going to be multiplying the probabilities, and that's going to end up just giving us the outcomes that they both have in common. Okay, so a couple of definitions, and then we'll look at our notation. Independent events. For independent events, the occurrence of one event does not affect the probability of the second event. If they're dependent events, the occurrence of one event does affect the probability of the second event. So if your first event that you choose, whether it's flipping a coin or drawing a card or whatever it may be, if it has no effect on the second event that you're about to do, I guess, for lack of better words, those would be independent events. If the first pick will ultimately affect the second pick, they would be dependent. So that's what this is going to show you here. If A and B are independent events, the probability of A and B both happening is the probability of A times the probability of B. So AND means multiply. If they're dependent events, there's actually nothing really added to the formula or the equation here. There's just something you have to consider for the second event. So probability of A and B both happening is the probability of A times the probability of B after A already happened. Okay, so what really happens here is this denominator kind of changes, or not, well, this denominator, sorry, would change if they're dependent events. Sometimes the numerator might be affected as well, and this you could make a connection with lesson 12.6 with permutations and combinations whenever you have repeats or no repeats. So a lot of connections can be made in this lesson. I also have some notes here. In this book, it doesn't use this notation, but in Algebra 2, it definitely does, and in your high school classes further down, they will. It could be phrased instead of B after A happens, it would be phrased as B given A, and that's the symbol you would use. It's kind of like that such that symbol. So I wanted to bring that to your attention. The statistics teacher from the high school levels want to make sure that we introduce it as soon as we can. So your book, again, uses the B after A. These are all the same thing. B given A, that means that what is the probability of B given that A already happened, and that's the notation for it. Okay, so let's take a look at a few examples here. For Got It 2, we're going to roll a red number cube and a blue number cube. What is the probability that you roll a 5 on the red and a 1 or a 2 on the blue? Well, we're looking for 2 different outcomes of 2 different number cubes. So these are going to be independent events. What we roll on the red is not going to affect our outcome for the blue. Okay, so you may not write these out completely like this. This is just me getting organized. Honestly, if you're looking for the 1 compound probability, you don't even need this top line. But some teachers might require it, so it is good practice. So the probability of getting a 5 on the red and a 1 or a 2 on blue means we're going to multiply the 2 separate probabilities, and because these are independent events, we have nothing we need to consider when we're doing our 2 separate probabilities. So a 5 on the red would be 1 out of the 6 outcomes on a number cube, and a 1 or a 2 would be 2 out of the 6 for the blue number cube. I reduced, but if you have a calculator, you might not need to, or you could just reduce at the end, but always reduce. 1/18 would be the answer for Got It 2. Okay. Moving on, Example 3 and example 4 are both going to be different from the book. Both of them required quite a bit of drawing into the notebook, so I decided to use an additional example just to save you the agony of trying to figure out what my drawings were, although I'm sure you all missed my beautiful drawings during math class. So example 3, a bag contains 4 red, 3 green, 6 blue, and 5 black chips. Andrew selects a chip at random. He replaces the chip, then selects another one at random. What is the probability, oops, typo, that he selects a red chip, then a black chip? So this right here doesn't specifically say the word and, but we know that they are going to be an and scenario because we're picking one and then another. So I even wrote that out here, probability of red and then a black. Well, we are putting the first chip back. So here I added up all my chips. So I have 18 total chips. If I pick a chip, or if Andrew picks a chip and puts it back, the second probability is not impacted by the first. So this is actually going to be still an independent event with replacement. Anytime you see this with replacement phrasing or something similar to it, those are going to be independent events. So we need to find the probability of getting a red. We put the chip back times the probability of getting a black. So 4 out of the 18 times 5 out of the 18. I went ahead and did some reducing. Again, you have your calculator, so as long as you reduce at the end, you get 5 over 81. By the way, I probably should have mentioned using your calculator. Most of your calculators default to decimals, but these are not going to be the neatest decimals, and you would end up having to round, and we are not rounding. So use that fraction to decimal button, change your answer back to a reduced fraction before you write your final answer down. No rounding, okay? Okay, and then just to clarify once more, even though this specifically does not say and, when you see then something happening, so one event, then the other, that is always going to be an and scenario. Okay, example 4. We're going to use the same situation as example 3 with all of these chips. We have 18 total, but this time suppose Andrew does not replace the first chip he selects. What is the probability that he selects a blue and then a green? So these are going to be dependent events. Okay, so we have 18 total chips. We want blue, so 6 of blue, and then we have, how many? 3 green. Okay. These are going to impact each other. If we pick a blue first and we don't put it back, we no longer have 18 chips. We now only have 17. So our notation, probability of blue times the probability of green after blue or green given blue. So I wrote it 2 different ways there for you. Okay, but don't get caught up on the notation. What's happening is we have 6 out of the 18 are blue. We don't put it back, so now we only have 17 total, 3 of which are green. We multiply and reduce, we get 1/17. So a note here, anytime it's without replacement, or any type of phrasing like that, those are going to be dependent events. Without replacing your first choice, it's going to impact the probability of your second choice. Okay, and then got it 5, our final example here, and I even, with the star down here, I added an extra piece. Okay, here we have, and we're back to the book if you're following along, 1 freshman, 2 sophomores, 4 juniors, and 5 seniors all received top scores in the school essay contest. To choose which 2 will present their essays, 2 names are drawn at random from a hat. What is the probability that a senior and a junior are chosen? So this specific scenario does not flat out tell us with or without replacement. However, you're not going to choose the same student to read the essay twice. So this is going to be without replacement, which means dependent events. Okay, so the probability, what is the probability that we choose a senior and then a junior? So probability of a senior times the probability of a junior after the senior. Well, there's 12 total students, 5 of which are seniors. So 5 out of 12 times our denominator drops to 11 because we already chose 1 student. 4 remaining students are juniors. Multiply, reduce. Okay. The only way this really gets any trickier for this year is where it would affect, where dependent events would affect your numerator and your denominator. So that's why I added this last piece. What if we want to find the probability of picking a junior and then another junior? Or it might just be phrased as picking 2 juniors, which would imply we picked a junior without replacement, we picked another junior. Okay, so what we would do is we'd find the probability of picking a junior times the probability of picking a junior after that first junior was already selected. So out of the 12 for juniors, we don't put that name back in the hat. Now we only have 11 total students, but we already picked a junior, so there's only 3 total juniors left. So this is where the numerator and denominator are both impacted based off of the scenario we're looking at. We multiply and reduce and write as a fraction. Okay, so that wraps up notes for 12.8. And that is the end of our chapter as well. So if you have any questions that these videos did not address, make sure you reach out and ask so that we can get through this chapter successfully and move on to our next chapter.